All right. Hey, everybody. This is Don from Padlock Technologies again. And this lab this time is going to be about optimal route reflection. Now, I did a video on this before, but I just went over the theory, and now we're going to do it in the lab, and you're going to see the lab. This is a pretty intensive lab. Let me give you a warning here. You need to know about normal routing protocols, how distant vector protocols, how link state protocols work before you can even do something like this. So let me explain how this lab actually works. So as you can see, I have two route reflectors here, and these are all IOSXRs. You can do this on IOSXE as well, but I just decided to do it in IOSXR. So we have two route reflectors. Then we have router 1, 2, and 3 are going to be my PEs that connects to this PE or this CE up here, which is technically in another BGP ASN. So this is going to be 65002 up at the top here, and these three PEs down here, which is 1, 2, and 3, are going to be in BGP ASN 65001. This whole thing here in yellow is 65001. And then we're going to have a PECE combo down here just for, labbing purposes. And this is going to be routers 5, 6, and 7. So what's going to actually happen is, and how I explained it in the theory before, is I am advertising a quad zero down. So let's take a look here. And let's log in. And if I look at the BGP table, you will see that I am advertising this quad zero. This is technically a null route for demonstration purposes. But what I'm going to do is I'm going to advertise this quad zero down to routers 1, 2, and 3. And if you look in the middle here, you're going to see a bunch of different cost values, right? Now, these cost values I put them in play to basically manipulate the path on how 5, 6, and 7 get to those quad zero. And this is where optimal route reflection comes into play. Because without optimal route reflection, 9 times out of 10, all paths are the same. It's going to go to router 1, right? If all paths are the same. But since I manipulated the path, the different cost values in ISIS for each link, what's going to happen is router 5 will pick router 1 because it's going to run, you'll see what I'm talking about. Router 6 is going to pick router 2, and router 7 is going to pick router 3 because the route reflectors are going to run this thing called reverse SPF. And what that is, if you know how the SPF algorithm runs, basically whoever's running the SPF algorithm is the root of the tree, right? So you get the graph and then you run the algorithm on the graph, and that's how you get the shortest path tree. So what the route reflectors are doing is they're not running the calculation based on their point of view. That's in theory video, I went over this, but that is the downfall of using a route reflector. It can produce suboptimal routing because it's going to give you the best path according to the route reflector's point of view, not the individual PE's point of view. And you can end up going to a router that's not close to the entry point or anywhere near the entry point because the route reflector said that was the best path. So what optimal route reflection does, it is going to run reverse SPF, which is it's going to not say I am the root. It is going to run the algorithm saying that router 5 is the root, and then it's going to say router 6 is the root, then it's going to say router 7 is the root, and then based on that calculation, it's going to send, hey, this is your best path, this is your best path, this is your best path. Now, in order to do this, you need to distribute the link state information, which is the links, right? The link information to the route reflectors in this. You have to do that under the IGP, and then you have to use this address family or AFI sub AFI called link state. It's literally called address family link state link state. Once you do that, you're going to see the actual link state information, and then you run your ORR, your ORR have a database, and then it'll look all those link attributes, and based on those link attributes, it is going to pick the best path. So the optimal path, thus the term optimal route reflection. So first things first, we are going to look at, let's open up this route reflector here, and we are going to log in. Now, what we're going to do is we're going to validate, I'm going to validate here that all my neighbors is up. You see those 3 prefixes coming here. That is the quad zeros coming from router 1, 2, and 3. And then you don't see anything coming from 5, 6, and 7 because I'm not advertising any routes, right? Now, if we're going to look at the link state database, which is the AFI, sub AFI, link state, when we show BGP link state, dupe, I think it's link state, sorry. Link state. Now, as you can see, this is the link state information. So this is technically the nodes. This is the link information. This is everything that BGP can carry. You'll be surprised at what information BGP can carry. That's why BGP is in a lot of technologies, because you can carry a lot of different NLRI in it, right? Network layer reachability information. So if we do the show ORR SPF database, you can see this is the database. So all these cost values per node is showing up. So every link has a cost value. So this is what it's using to create that calculation, right? And then if I do show BGP, IPv4 unicast, you can see the best path from the route reflectors point of view is router 3. Now, in normal situation that you're not doing ORR, I would be sending, hey, my best path is router 3. Everybody goes to router 3. That's what would happen. But that's not going to be the optimal option, because some of these links are 30 going to router 3 when it should be, router 1 or router 5 should be going to router 1. If I didn't have optimal route reflection, since the route reflector said, hey, go to router 3, it just went to router 3, even though that's not the best link, right? What else is it that I want to show you? Let me show you some I'll show you some ISIS configurations. So if we look at our ISIS configurations here, this is the stuff that we need to put into play. So we're distributing the link state information into the IGP, so that when we do BGP link state, it sends that information from the IGP into BGP, and we have to turn on MPLS traffic engineering, because if you don't do that, this will not work. This will not work at all, actually. Now, from a BGP perspective, since we're on the route reflector, now you can use neighbor groups for this, but this is technically your optimal route reflection information or configuration that you need to do. And then, as you can see, link state, and all that stuff. Here's my neighbor group that I have here. Now, your neighbor group is sort of like peer groups in normal iOS, and then there's template peers in iOS XE when you're doing your BGP configuration. Normal iOS just does a peer group, but this is pretty much the same thing as that. You see the route reflector on both of them, so that means routers 1, 2, and 3, 5, 6, and 7 are going to be route reflector clients. Now, this is the key piece here, optimal route reflection. So that goes into this group here, and then under unicast, you have to apply it. Now, you only have to do this part here with the apply in iOS XR. You do not have to do this in iOS XE, but this is an iOS XR kind of thing. So the main point is, once you have the neighbor group, you have to go in here and say, hey, this is going to be a route reflector, and this is going to run optimal route reflection for that router. And that router group is tied to this IP address here. All right. So now that that's done, what's going to end up happening, as I did it with another route reflector on the other side. So this is router 8, and router 4 pretty much has the same configuration on it. The only difference is I'm running just normal BGP IPv4 and link state, no route reflector client between both RRs. So if you look at the BGP information, they're pretty much the same. All right. So now here's where the rubber meets the road. Now remember what I said is that each individual PECE is going to pick a different path based on these calculation and cost values to go to its separate or the best PE, egress PE to get to quad zero. So let's validate that. So if we log into this, just move this over here. So if we log into this and then we go show BGP IPv4 unicast, as you can see, that router 5 has picked router 1 like it should because the cost value is 10. So it picked this link to go there. Pick router 1 to get there because that has the least cost to get there. It did not pick 2 or 3 because the cost value respectively 2 is 20, 3 is 30, lower cost wins, so it picked 10. So if we go to router 6 though, and we do the same thing, you will notice that it picked 2, right, instead of 1. And why is that? It's because according to the route reflector, when it got all that information, it said, okay, for you, number 2, I'm going to run that SPF algorithm for you as you and you are the root. Based on you being the root, your cost value of 10 is the better route. So you're going to go to 2 instead of 1 because 1, your cost value to get there is 30 compared to 10. So that's why I picked router 2. And 7 is going to pick router 3. And that's because the same thing. Route reflector did reverse SPF on the graph with router 7 as the root. It looked and said, okay, based on the link state information that you gave me and the stuff that I've seen, I see that router 3 is the best option because the cost value to that is 10 according to my ORR database. So I'm going to tell you that you're going to go to router 3 to get to quad zeros, and the other one went to 2, the other one went to 1. So that is a brief discussion on our brief lab and discussion on optimal route reflection. Like I said before, if you're going to do something like this, you need to know how IGPs and BGP work in tandem. You actually have to know the AFI, sub AFI, what to look for, why you're sending that information, if there's any issue. From a routing perspective, or if there's any issue with some link state information that you're not advertising, obviously this won't work. You need to distribute link state in the IGP again, so you can, when you do the AFI, sub AFI of link state, it will send that information in the BGP NLRI. And then also, because I made this mistake earlier too, make sure when you're doing there's a key thing in iOS XR, which if you haven't dealt with it before, or if you haven't done with it for a long time, when you are doing a neighbor relationship between 2 different ASNs, right? So I got 65001 and 65002. In order for you to actually accept routes from there, you have to have a route policy that allows that route to come in and out, right? It allows the stuff to be routed in and out. So you got to have a route policy, and I just made a simple one called pass for this lab. Pass. All right. And that pass keyword just basically says, hey, allow everything in, allow everything out. There's no conditional value. And this is RPL. It's kind of like a programming language. There's no such thing as a route map really in iOS XR, but the route policy is basically what you would consider the route map in iOS XE and iOS. Right? And where you would see that is in my BGP configuration right here, because this is going to router 9. If you don't have that route policy in and out, you won't be able to accept routes or send routes. And then for your route reflectors, you better make sure you do next hop self, because if you don't do that, what's end up happening is it will send the route to the route reflector with the external IP address as the next hop. The route reflector doesn't know how to get there, so it will not install the routes in the routing table to run ORR on. And that's pretty much the first rule with BGP path selection. If I can't even get to the next hop, I'm not going to run path selection and all that. So again, that was a little side quest, but that was a quick tutorial or brief discussion lab so you can see it live of BGP optimal route reflection. Hopefully this was informative. Don't forget to share, comment, like, and subscribe. Keep sending me those questions and I'll keep getting you those answers. Thanks and have a nice day.